Alright, in this lesson, you're going to learn how to factor trinomials with a leading coefficient other than 1. So notice that the coefficient of the square variable is a number other than 1. And I'm referring to this 7 right here. I'm going to teach you the AC method to factor these types of trinomials. And we're going to call it the other case. In the last lesson, we went over what case. So I mentioned a word in the last section that I referred to trinomials with a leading coefficient of 1. So what did I call that case? I'll call that case the easy case because there weren't a lot of steps to that type of situation. But in this case, this other case, there are a couple more steps. So let's break down this trinomial of 7x squared plus 17x plus 6. The AC method is referring to the A, and let me write this so you're familiar with ax squared plus bx plus c. So when I'm saying A, I'm referring to the leading coefficient, and C is referring to the constant. So 8 is the leading coefficient and C is the constant. So when I say AC method, then you know what I'm referring to, the leading coefficient and constant. So the first step is to multiply the leading coefficient, the number in front of x squared, times the constant term. And here we have 7 times 6. What is that? That's 42. Now that is the number that you're going to put on your T table now. So you're going to put 42 up here. Now this step doesn't change, where you find the factors of that number you put above the T table. The previous steps change because we had to multiply A times C, but this step doesn't change. We put 1 in 42, we put 2 in 21, 3 in 14, 6 and 7, because those are the factors of A times C. Now, this step also doesn't change. Which pair adds up to be the middle coefficient, or B? So we figure out that 3 and 14 works, right? Because 3 plus 14 is 17. Now, the next step is different. We're going to expand this trinomial here. Erase this. We're going to expand the trinomial here into 4 terms. Now notice that the 7x squared is the same, and the 6 is the same on the ends. So the ends are the same, but what is different? The middle is different. Only the middle is different, right? And the middle consists of that 3 and 14, right? So we expanded the 17x that's in the middle here. We expanded this to 3x and 14x, or 14x and 3x. So you could have written this 4 terms as 7x squared plus 3x plus 14x plus 6. That would have worked as well. However, notice that 7 and 14 are obviously have something in common. They obviously have something in common, and 3 and 6 obviously have something in common. So that's why I put the 14x with the 7x squared and the 3x with the 6. However, it would have worked the other way, believe it or not. Then once you expand it to 4 terms, of course, when you hear the 4 terms, or when you see 4 terms, what should trigger is factor by grouping. So that's why in the first group we have 7x in common. 7x is in common with the first group. So this is group 1. And we take the 7x out and we have x plus 2. And then in the second group, 3 is in common. So we take that plus 3. And please, please, please put a sign here, always. Take the 3 out and we have another x plus 2, which is called our common binomial factor. So we have common binomial factor here. That's like our GCF. So we take that out to finish the problem. We put that first, take out the GCF, which is x plus 2. And if you factor out the common binomial factor, you have the 7x plus 3 left over. And you can always check that, of course, by multiplying your factors. Make sure that when you multiply your factors, and I'm going to go ahead and do it really quickly. X times 7x is 7x squared. X times 3 is 3x. 2 times 7x is 14x. 2 times 3 is 6. So what you have is 7x squared plus, like terms here, 17x plus 6, which checks out. Now, let me also state and reiterate that you could have also written the answer. So alternatively, the answer 7x plus 3 times x plus 2 is also correct. So depending on how you wrote those middle terms, your answer could have come out to be this instead. If, for example, if you put 3x first and then 14x. But I want you to keep in mind they are the same. Multiplication is commutative, so the order of the parentheses do not matter as long as you have the same signs. You're carrying the same signs over. So always check your factors before you move on to the next problem. All right, let's begin. So here again, we have a leading coefficient that's not 1. And when that happens, I want you to follow the steps above. And we're going to call it the AC method. So these are the 5 steps I want you to go through when your leading coefficient is not 1 and you have a trinomial. So let's begin. What you're going to do is multiply A times C. So you're going to get 12 here. So place A times C here. So we have 12. Write all the factors out for 12 and figure out which of the pairs will add up to be the middle coefficient, which is B, and that is 13. So if you added 1 plus 12, you would get 13 here. All right, so next you would rewrite the first term back over. The last term will remain the same, but we are expanding that middle to 2 terms. That's why we have 4 terms in all once we're done. We're expanding 13x, and we're using that 1 and 12, right? But we have to include the x's in order for the like terms to add up to 13x, right? So that's why you either write 1x plus 12x or 12x plus 1x, because the middle adds up to be 13x. Now, if you did not include the x's, it would not add up to be 13x, and you just altered the entire problem. So your answer will automatically be wrong, because this step must be the same as this. These must be equivalent. in order for our answer to come out correct. So now that we have 4 terms, let's factor by grouping. So again, I wanted the 2 to be matched with the 12, but it doesn't matter. You could have grouped 2x squared with 1x. Alright, but since I grouped it like this, 2x, I'm going to take a 2x out of the first group, and that'll be x plus 6. And we have the second group here. We have the x plus 6, but that's why I wrote the 1, so you can know that we have to put something here, and it works because 1 times x plus 6 is x plus 6. We have the same thing here, so we can take our common factor x plus 6 out, and x plus 6 times what will give us back the first part here. What will give us back all of this? X plus 6 times what? It'll be 2x, for example, plus, again, what will give us back all of this? It will have to be just the 1. But you can always check that by doing what? If you said multiplying or foiling, you are right. Moving on to the next one, 5x squared plus 7x plus 2. Again, if you kind of get this, try to do it on your own. Pause the video and try to do it before you see the answer. But we have 5 times 2, which is 10. And we have 1 and 10 and 2 and 5. What will add up to give us 7, 2 and 5. Again, we rewrite 5x squared. We rewrite the 2 plus 2. And we always carry the sign that's in front of the numbers, right? So that's why I put plus 2. But the middle would be the 2 and 5, but keeping in mind that the middle here is 7x. So that's why we have to put either 2x plus 5x or 5x plus 2x. It doesn't matter, okay? But since this is an obvious common factor in this, that's why I put those together. So 5x times x plus 1 works, and then we take our 2 out, and we get that x plus 1 again, which is what we want. So x plus 1 times 5x plus 2. And again, you could have written 5x plus 2 times x plus 1. It's the same. Always multiply it and make sure though. Then you have 3x squared plus 11x plus 6. We have 3 times 6, which is 18. Factors of 18 are 1 and 18 and 2 and 9. 2 and 9 will work because when you add 2 plus 9, you get 11, which is the middle term. So that's why that works. And you multiply, you get the 18, the positive 18 that you want. So we have 3x squared. Then in the middle, you put 2x plus 9x or 9x plus 2x. All right, plus 6. All right, so here we're going to group. We have 3x times x plus 3 plus 2 times another x plus 3, which works out. So it's x plus 3 times 3x plus 2, or what else would work? If you said 3x plus 2 times x plus 3, you are correct. Moving on to number 4, we have 8 times 5, which is 40. Factors of 40 are 1 and 40, 2 and 20, 4 and 10, 5 and 8. Factors of 40 are 1 and 40, 2 and 20, 4 and 10, and 5 and 8. What will work so that when we add our pair, we get a negative 22. So if you said a negative 20 and a negative 2, because if you multiply this, you get the positive 40, then you are correct. So 8x squared minus 2x minus 20x plus 5. Then we group. You can take out a 2x, 4x minus 1. And then for negative 20, and we're looking at negative 20 plus 5, what could we take out of that? So if we took out a negative 5, it will work out because then we get that positive 4x here minus 1. So the final answer is 4x minus 1 times 2x minus 5. Moving on to number 5, we have a is 2 times negative 7. And let me say this too, because I'm not reiterating it now, but it's important that you know that you always look for the GCF first. These do not have GCFs. So 2 times negative 7 is negative 14. Factors of positive 14 are 1 and 14, 2 and 7. But what will work so that when we add, we get the positive 13 that we want. But when we multiply, we get negative 14. So if you said negative 1 and positive 14, you are correct. So we have 2x squared plus 14x minus 1x, or vice versa. You could have written 2x squared minus 1x plus 14x minus 7. So we group, take out a 2x, x plus 7. And since we want x plus 7 back, we take out a negative 1 to flip those signs. So we have x plus 7 times 2x minus 1, or 2x minus 1 times x plus 7. Moving on to number 6, let's take a look at some other types of trinomials. 10x squared minus 13xy minus 3y squared. As you can see, we do not have a leading coefficient of 1. So we do have a trinomial because we have 3 terms. So let's try the AC method. So we're going to multiply 10 times a negative 3 to get negative 30. Factors of negative 30 are 130. Well, let's do the positive factors. 2 and 15, 3 and 10. But what will work so that it will add to give us negative 13? Well, let's try a negative 15 and 2, because when you multiply this, you get the negative 30 you want. But when you add it, you get the negative 13 you want. So when we rewrite this, we have 10x squared. In the middle, we needed to add up to be negative 13xy, right? Xy, which means that we need to put an xy on the end of our numbers 2 and negative 15. Right? Because we need the middle to be the same as the middle up here. So they must be the same, and it works out. So now we factor by grouping. We take out a 2x, we get 5x plus y. And what does negative 15xy and negative 3y squared have in common? Well, it looks like you take out a negative 3y and you get that 5x plus y again. So the final answer is 5x plus y times 2x minus 3y. And for these type of problems, it's not a mystery whether you got the answer right or wrong, because you can always multiply them to check to see if you are right or wrong. All right, moving on to number 7. We have 3x to the 4th minus 5x squared minus 8. Still notice that we have a trinomial because we have 3 terms here. And then because we have 3 as the leading coefficient, we're going to multiply the 3 times the negative 8 to give us a negative 24. Factors of 24 are 1 and 24, 2 and 12, 3 and 8. What will work, or 6, what will work so that and let me just say that you don't have to write all the factors out once you realize that you have landed on the correct pair. And I almost didn't write the 4 and 6 down because I saw that 3 and negative 8 would work, because, and again, let me just say this as well, only one pair will work. You're not going to have 2 pairs that could work. Only one of these will work, and this one works. Okay, you're not gonna have one. It wouldn't be possible for the others to also work. So we're gonna rewrite our first and last terms, 3x to the 4, but in the middle we need it to add up to be negative 5x squared. So what do we need to put on the ends of 3 and negative 8? It would have to be x squared for it to work out, so that this is equal to this. Then we're going to rewrite the end here, minus 8. Let's group. Now what we have in common here is a 3x squared. Then we have times x squared plus 1. And we also have a negative 8 in common, and that's why we'll also get x squared plus 1. So what is the final answer for this particular problem? The final answer is x squared plus 1 times 3x squared minus 8, or vice versa. Moving on to the problems here, factor out the greatest common factor. Sometimes you will encounter problems that you must take the GCF out first. For example, for this particular problem, you need to take out 2m squared first, which will leave you with 12m squared plus 20m plus 3. Notice though that this is a trinomial, and it's the other case, meaning the leading coefficient is not 1, because notice it's 12, right? So that means this could be factorable. So you're going to have to use the AC method, and you're going to have to multiply your A times the C, for example. So here we have 12 times 3, which is 36. The factors are 1 and 36, 2 and 18, 3 and 12, 4 and 9. What would work so that it would add to be the B of that trinomial? And the B of that trinomial is 20. So what would work is 2 and 18. So when we rewrite this problem, we could write it as 2m squared. We have 12m squared. We're about to expand this to 4 terms. So we have plus 2m plus 18m plus 3. And now we're going to factor by grouping. So I'm going to go to a bracket now. Notice we can take out a 2m here, and that's 6m plus 1. And over here we can take out a 3, and that's 6m plus 1. So continuing this, we have 2m squared. On the inside, we're going to have 6m plus 1, because that's the common binomial factor, times 2m plus 3. So 2m squared times 6m plus 1 times 2m plus 3 is the right answer. Again, you don't have to write it in this order per se. It could have been 2m squared times 2m plus 3 times 6m plus 1. Let's move on to the next one. Notice again, we have a negative in the front. What you could do is factor out that -1 first, and we have, let's say that's your GCF. Then all of our signs will switch in the inside of that parenthesis, and then you're going to work with this trinomial here. So notice that A times C will give us -30. Factors of -30 or positive 30 is 1 and 30, 2 and 15. But what will work so that we get a positive 13? So we will have to go with a -2 and 15. So here we keep our -1, 6x squared. We're going to span that middle term to -2x plus 15x, and then minus 5. Then you can factor by grouping, because you have 2x times 3x minus 1 plus 5 times 3x minus 1. That's what you want. You want this to be the same as this, right? So finally we get the answer -1 times 3x minus 1 times 2x plus 5. And this could be -2x plus 5 times 3x minus 1. That 1 in the very front is understood. As long as you have that negative, you are good. Next, we have another situation where we have a GCF, because we have something in common with all three terms. So we always have to take care of that first thing. And so we take out the 5x first, or we'll have some issues. So we have 3x squared plus 8x minus 16. This is a trinomial. We must use the other case, or the AC method, because our leading coefficient in this case is 3. So we multiply 3 times -16 to give us that -48. 5 factors of 48. 1 and 48, 2 and 24, 3 and 16, 4 and 12. What would add up to give us the positive 8? But at the same time, multiply to give us -48. So if you said -4 and 12, then you are correct. So we have 5x. We're going to have a 3x squared. Let's expand that middle to -4x plus 12x minus 16. And then you will have 4 terms, and then that's when you factor by grouping. So you take out an x, for example, out of the first group, and you have 3x minus 4. And in the second group, it looks like 4 is in common. You get another 3x minus 4, so it works out. So final answer is 5x times 3x minus 4 times x plus 4. So this concludes this lesson on factoring trinomials when the leading coefficient is not 1.